Stephen Hawking wrote down an astonishing equation. It would include relativity, it would include quantum mechanics, and it would include information. Hawking's rather simple equation brought us a step closer to understanding the relationship with quantum physics and black holes.
When an object crosses over the edge of a black hole, its event horizon, the object enters a realm basically of empty space, of darkness, and it continues to be dragged toward the center of the black hole, toward what we call the singularity, where it gets crushed out of existence. Every object, in some sense, contains information because it contains a very specific arrangement of particles. So where is the information that describes the arrangement of those particles? Where does it go?
Hawking's description of this process was that the energy remains, but the information disappears.
For many years, for decades, people wondered, is Hawking right? Is the information obliterated and disappears from the universe, or is it still there and perhaps can be in some way retrieved? Is the information obliterated and disappears from the universe, or is it still there and perhaps can be in some way retrieved?
The destruction of information was counterintuitive, and it didn't match the rest of the things we knew. In all parts of physics, we had a situation where information doesn't get destroyed. So it was a bit puzzling.
This debate furiously went back and forth up through the 80s and into the 90s when people finally began to articulate this new principle, this holographic principle. And what it said is that all the things that were falling inside a black hole were somehow captured in a preserved image at the horizon itself.
So if the information is not lost on the surface, the information is not lost inside because they are equivalent.
All the information about those objects, what they were like in their three-dimensional existence, was preserved or encoded on the surface of the black hole. And that's a little bit like a hologram.
Well, that suggests that maybe that idea may apply more broadly to the universe as a whole. Maybe the three-dimensional objects, us, everything in the world around us, maybe all of the information in these objects is carried, is smeared around a distant two-dimensional surface that surrounds us, and we're just in some sense a holographic projection of that distant data.
The holographic principle tells us something quite astonishing. It says that our ideas of volume, of the real world in a sense, might be a kind of illusion.
Here's a way to think about this. Imagine I took my wallet and threw it into a black hole. What would happen? We used to think that since nothing, not even light, can escape the immense gravity of a black hole, my wallet would be lost forever. But it now seems that may not be the whole story. Recently, scientists exploring the math describing black holes made a curious discovery. Even as my wallet disappears into the black hole, a copy of all the information it contains seems to get smeared out and stored on the surface of the black hole, in much the same way that information is stored in a computer. So, in the end, my wallet exists in two places. There's a three-dimensional version that's lost forever inside the black hole, and a two-dimensional version that remains on the surface as information.
The information content of all the stuff that fell into that black hole can be expressed entirely in terms of just the outside of the black hole. The idea then is that you can capture what's going on inside the black hole by referring only to the outside.
And in theory, I could use the information on the outside of the black hole to reconstruct my wallet. And here's the truly mind-blowing part. Space within a black hole plays by the same rules as space outside a black hole or anywhere else. So, if an object inside a black hole can be described by information on the black hole surface, then it might be that everything in the universe, from galaxies and stars to you and me, even space itself, is just a projection of information stored on some distant two-dimensional surface that surrounds us. In other words, what we experience as reality may be something like a hologram.